After John Glenn became the first American to orbit Earth on February 20th, 1962, his fellow astronauts began to fly longer and farther into space. The one-man Mercury spacecraft gave way to the 2 men in the Gemini program, and then to 3 in the Apollo spacecraft. As astronauts walked in space and on the moon, scientists and engineers dreamed of journeys to other planets. These other worlds remained out of reach for astronauts, but not for human technology. Unmanned spaceships flew by, orbited, and then landed on Mars. I'm Jim Lovell, and I was fortunate to fly on 2 Gemini and 2 Apollo missions. This volume of America's achievements in space brings you right there. You'll ride in a Gemini spacecraft, walk in space, and see the surface of the moon from the windows of an Apollo command ship. You'll also see startling photographs of Mars sent back to Earth from 100 million miles away by Mariner 9. Using the pictures from this unmanned mission, Carl Sagan, the well-known scientist and author, narrates the surprising discoveries that were made. And he and other experts also described the search for life on this mysterious planet. These tapes, made directly from the films in NASA's archives, represent the official historical record of this exciting era of exploration. The United States launched the first mission in history to Mars in November 1964. Mariner 4 was still on its way to Mars in June 1965 when Ed White and Jim McDivitt orbited the Earth aboard Gemini 4. You'll feel like you are there with Ed as he walks around the ship while it orbits 100 miles above the Earth. On Gemini 7, Frank Borman and I set a record of 13 days, 18.5 hours in space in December 1965. The American space program was progressing rapidly, but tragedy struck on January 27, 1967, during a test at Cape Canaveral. A flash fire aboard an Apollo spacecraft took the lives of Ed White, Gus Grissom, and Roger Chaffee. It took us almost 2 years to get back to the point where astronauts could safely fly in space again. But by December 1968, NASA was ready to break the gravitational bounds of Earth and send men to the moon. In the Apollo 8 mission, Frank Borman, Bill Anders, and I would travel faster and farther than any men in history. In this tape, you will see the lunar surface as we saw it for the first time. And you'll see the marvelous view of the Earth from 240,000 miles away. It is a view that has changed the perspective of many people, including me, when I realized that our planet is a beautiful oasis in the vast desert of space. See if you agree when you see the Earth as we did.
December 21st, 1968. The shortest day of the year, but in significance, perhaps one of the longest in the flow of history.
This is Apollo Saturn Launch Control. We are still go at this time. T-minus 15, 14, 13, 12, 11, 10, 9. We have ignition sequence start. The engines are on. 4, 3, 2, 1, 0. We have commit. We have liftoff. Liftoff at 7:51 a.m. Eastern Standard Time. We have cleared the top.
Tower clear, 13 seconds.
The United States was undertaking the most distant voyage ever attempted by man. For the first time, 3 Americans rode the Saturn V moon rocket.
Apollo 8 Houston, you are go for staging, over. Staging. Our certain plates up. Roger, understand, sir. We hear you loud and clear, Apollo 8.
Okay, the first stage was very smooth, and this one is smoother.
Apollo 8 Houston, your trajectory and guidance are go, over.
Thank you, Michael.
Yeah, you're looking real good, Frank.
Frank Borman, Jim Lovell, and Bill Anders were about to leave their cradle Earth and face the infinite frontier.
Apollo 8 Houston. Go ahead, Houston. Apollo 8, you are go for TLI, over.
Roger, understand. We're go for TLI.
TLI, Translunar Insertion. This was the commitment. Borman, Lovell, and Anders were ready for the maneuver that would send them to the moon. As the world listened and watched, its people were overtaken by a new awareness, an awareness that they were perhaps witnessing the overture to the ultimate destiny of man.
Lovell confirms ignition. And the thrust is okay, Booster says.
On board the spacecraft and in mission control, the men of Apollo 8 watched the readouts. Velocity buildup in feet per second. The numbers snowballing toward the velocity that would allow the spacecraft to escape Earth's gravity.
Okay, we got Nico.
And Borman says we've got Seco. Cutoff was right on the second.
With the cutoff of their third stage engine, Apollo 8 was traveling faster than had any men before, a coasting uphill climb against the pull of their native planet. Now the third stage, the S-4B, was just useless mass to them. It was jettisoned, then later placed into an orbit around the sun. The crew of Apollo 8 turned around for a look.
Houston, Apollo 8, how do you read? You're loud and clear, Frank. How are you?
Roger, we're loud and clear. We're taking pictures of the S-4B. The post-separation sequence is completed, and we seem to have a high gain.
Give us clues to what it looks like from way up there.
Roger. I can see the entire Earth now out of the center window. I can see Florida, Cuba, Central America, the whole northern half of Central America, in fact, all the way down through Argentina and down through Chile.
So you picked a good day for it.
Houston, for information, I'm looking through the scanning telescope now, and I see millions of stars, most of them venting from the S-4B.
The crew of Apollo 8 now settled down to the routine of the outward flight. Systems checks, observations, navigational star sightings.
Jim, they've just been looking at your marks with respect to accuracy, and they figure they're within a couple thousandths of a degree of the theoretical optimum.
Lovell's proficiency in navigating the spacecraft with its onboard optical instruments would eventually earn him the nickname the man with the golden fingers. His speed was such that he would be requested to slow down so that the earthbound machines recording the data could keep up with him. The accuracy of his sightings was virtually flawless, symbolic of the entire mission. A mission so accurate that several of the planned mid-course corrections would be dropped as unnecessary. Astronauts, spacecraft, flight controllers, computers. The precision was fantastic. Then, on the second day out, the world looked in on the crew via television.
This transmission is coming to you approximately halfway between the moon and the Earth. We've been 31 hours, about 20 minutes into flight. We have about less than 40 hours left to go to the moon.
So Apollo 8 glided on silently, farther from Earth than man had ever before been. A microscopic dot of life in the cosmic void. Around the world, in Goldstone, California, Madrid, Spain, Canberra, Australia, the gigantic antennas of the Deep Space Network tracked Apollo 8, received its communiques, picked up the voice of its telemetry. Only for the 40 minutes of its transit behind the moon on each orbit would Apollo 8 lose contact with Earth. Then, on the day before Christmas, the network zeroed in on the spacecraft television antenna for the second broadcast to Earth.
Right, you're all looking at yourselves as seen from 180,000 miles out in space. Mike, what I keep imagining is if I'm some lonely traveler from another planet, what I think about the Earth from this altitude, whether I think it'd be inhabited or not.
You don't see anybody waving, is that what you're saying?
Well, I'm just kind of curious whether I would land on the blue or the brown part of the Earth. You better hope we land in the blue part.
Shortly after they turned off the television camera, Borman, Lovell, and Anders ended their long climb away from Earth. Crossing the point where the gravity of Earth and Moon just balanced, they became the first men to fall toward another celestial body. Now the time approached for the most immense commitment of the mission, Lunar Orbit Insertion, LOI. A burn of the service module engine would place Apollo 8 into orbit around the Moon. Up to this time, without further major maneuvers, the spacecraft would loop around the Moon and return to Earth. Once the burn was made, Apollo 8 would be held by the Moon's gravity field until a later burn would push it free.
Apollo 8, this is Houston at 6804, your goal for LOI.
Okay, Apollo 8 is go.
You're riding the best bird we can find.
Lunar orbit insertion would take place on the backside of the Moon. With the Moon between the spacecraft and the Earth, all contact would be lost until it appeared on the other side. In mission control, they anticipated LOS, loss of signal from Apollo 8. Now, mission control and the world could only wait. Wait for the first contact with Apollo 8 as it emerged from behind the Moon.
We've got it. Apollo 8 now in lunar orbit. There's a cheer in this room. This is Apollo Control Houston, switching now to the voice of Jim Lovell.
By 60.5, good to hear your voice.
The burn was as close to perfect as possible. Later burns would circularize the orbit, and the three astronauts would circle the Moon 10 times in 20 hours. Sunrise, sunset, every 2 hours on an alien world. And they would take pictures, still photographs as well as motion picture film, here seen at a much faster rate than orbital velocity.
Apollo 8, Houston, what does the old Moon look like from 60 miles, over?
Okay, Houston. The Moon is essentially gray. No color. Looks like plaster of Paris. Or sort of a grayish beach sand. We can see quite a bit of detail. The craters are all rounded off. There's quite a few of them. Some of them are newer. Many of them look like, especially the round ones, look like hit by meteorites or projectiles of some sort. Langrenus is quite a huge crater. It's got a central cone to it. The walls of the crater are terraced, about 6 or 7 different terraces on the way down.
The world saw and heard the first live telecast of the lunar surface.
Hey, Bill, how would you describe the color of the Moon from here?
The color of the Moon looks a very whitish gray, like dirty beach sand, and with lots of footprints in it.
Don't these new craters look like pickaxes striking concrete, leaving a lot of fine haze dust?
Scientist, engineer, astronaut, the world, all followed the progress of Apollo 8. For this was preparation, an advanced scout marking the way for those who would follow, those who would orbit, those who would land, navigate, track, observe, record, describe.
There's no trouble picking out features that we learned on the map.
Certainly looks like we're picking the more interesting parts of the Moon to land in. The backside looks like a sand pile my kids have been playing in for a long time. It's all beat up, no definition, just a lot of bumps and holes. The area that we're over right now gives some hint of possible volcanic, though I really can't eyeball it at the moment to pin that down. No, there are some craters and buildups that definitely suggest volcanic activity.
Then a Christmas Eve message the world could not forget.
Welcome from the moon, Houston.
Thank you.
The moon is a different thing to each one of us. I know my own impression is that it's a vast, lonely, forbidding type existence or expanse of nothing. It looks rather like clouds and clouds of pumice stone.
Beyond technology, beyond science, Apollo 8 was bringing to the world a new awareness, an expansion of mind and spirit that must forever alter the perspective of humanity, physically and philosophically.
And from the crew of Apollo 8, we close with good night, good luck, a Merry Christmas, and God bless all of you on the good earth.
There was little time for the crew of Apollo 8 to reflect. The next job was to make sure that the spacecraft was ready for the most critical maneuver of the mission, the firing of the service module engine for TEI, trans-Earth insertion, and the trip home. There was no go, no-go decision on this one. It had to go.
All systems are go, Apollo 8.
Thank you.
For the final time, Apollo 8 passed behind the moon, out of contact with Earth, for this most critical of all the burns. On the ground, men waited.
Apollo 8, Houston. Apollo 8, Houston. Apollo 8, Houston. Apollo 8, Houston.
Apollo 8, over.
Hello, Apollo 8. Loud and clear.
Roger. Please be informed there is a Santa Claus.
That's affirmative. You're the best ones to know.
3 very tired astronauts were on their way home. And with them rode an army of engineers, scientists, technicians, programmers, flight controllers, all those whose dedicated efforts were Apollo 8. After catching up on their rest, homeward bound, there was more a mood of elation, contrasted with the outbound loneliness.
I told Michael you guys are up there, and he said, who's driving?
That's a good question. I think Isaac Dukes is doing most of the driving right now.
We were enjoying the holiday, in the Christian world, Christmas, and we paused for a moment in our celebrations to watch 3 travelers heading home. As many of us sat down to our Christmas meal, Borman, Lovell, and Anders were enjoying theirs.
It appears that we did a grave injustice to the food people. Santa Claus brought us a TV dinner each, which is delicious. Turkey and gravy, cranberry sauce, grape punch, outstanding.
Roger, Jim. Glad to hear it. You know, we're down here eating cold coffee and bologna sandwiches.
As on the way out, there were periods of work. The navigational ability of the spacecraft and crew was proving phenomenal. And periods of rest, a single man on watch.
Well, Ken, that just leaves you or I. How about you and I? Anything exciting happen today?
Real quiet down here. Everybody's smiling. Everything's pretty calm, like it should be on Christmas.
Very good.
Yeah, Milt says we're in a period of relaxed vigilance.
Very good. We'll relax, you be vigilant.
The final television transmission, 97,000 miles out, farther than man had been on any previous mission, but now tantalizingly close to home.
I think I must have the feeling that the travelers in the old sailing ships used to have. We've gone on a very long voyage away from home, and now we're headed back, and I have that feeling of being proud of the trip, but still happy to be going back home and back to our home port.
Every second brought the spacecraft closer to its fiery entry, the final plunge to the safety of Earth. On the morning of December 27th, the word was given to Apollo 8. The pyrotechnic devices that would separate the command and service modules prior to entry were armed.
Apollo 8, Apollo 8. Your go for pyro arm. Everything's looking good.
Roger, everything's looking good here, Ken.
On schedule, the command module jettisoned the service module to expose the main heat shield, aligned itself to entry attitude, and slammed into the atmosphere at 25,000 miles per hour, faster than man had ever traveled until Apollo 8. A tracking aircraft took these films of the entry, the spacecraft seen as an incandescent fireball. With the temperature on the heat shield reaching 5,000 degrees, the communications were blacked out. The men in mission control waited once more.
Ken Mattingly just put in a call and just frankly labeled it a radio check. He's gotten no responses yet. Ken Mattingly puts in another call. And there's Jim Lovell.
We're in real good shape, Houston.
Real fine.
The landing was right on target. Later, Frank Borman would report passing over the recovery ship as Apollo 8 drifted down toward the sea on its parachutes. As Borman, Lovell, and Anders stepped onto the carrier deck, a huge and patriotic celebration broke loose in Mission Control. A celebration echoed by the hundreds of thousands of men and women who were Apollo 8.
Again, it's Apollo Control here. I'm not sure how well our voice is getting out. There is a tremendous roar, an undercurrent of roar in the background. And I have never seen the degree of this emotional outpouring in any previous mission, including Alan Shepard's. I've seen rallies in locker rooms after championship games. I've seen happy politicians after elections, but none of them do justice to the spirit pervading this room.
But the triumph of Apollo 8 was beyond the bounds of nationalism. It was a fruition of the ages of humanity. The first Chinese setting off a gunpowder rocket, the Englishman, Newton, the German, Kepler, the Russian, Tsiolkovsky, the American, Goddard. For one moment in history, the nations of Earth were united in the eternity of deep space. In Havana, in Washington, in London, in Moscow, in Tokyo. All of mankind joined 3 Americans, orbiting 60 miles above a stark, lifeless world.
In the beginning, God created the heaven and the earth. And the earth was without form and void, and darkness was upon the face of the deep. And the Spirit of God moved upon the face of the waters. And God said, "Let there be light." And there was light. And God saw the light, that it was good. And God divided the light from the darkness.
The vast loneliness up here on the moon is awe-inspiring, and it makes you realize just what you have back there on Earth. The Earth from here is a grand oasis in the big vastness of space.
Give us, O God, the vision which can see thy love in the world in spite of human failure. Give us the faith to trust the goodness in spite of our ignorance and weakness. Give us the knowledge that we may continue to pray with understanding hearts. And show us what each one of us can do to set forward the coming of the day of universal peace. Amen.
4 o'clock in the morning on June 3rd, 2 men arose in Florida. They began preparing for their day's work, as they had since June a year ago. Jim McDivitt, command pilot of Gemini 4. Ed White, pilot in the right seat. For the next few hours, they would systematically progress toward launch. The steps were now a normal routine. They had done them again and again. They had practiced flying Gemini 4 in a simulator. They had practiced emergency aborts. They had their temperature and blood pressure taken. One day in St. Louis, as part of the 1,001 things the crew did, McDivitt disassembled the locking mechanism of the spacecraft hatch. Later today, that would become important. But it was now June 3rd. A year had ended for these men. A year devoted to a single goal, flying a 4-day mission in Gemini 4. In America's first long-duration mission, Gemini 4 would complete 62 revolutions. The flight plan called for the spacecraft to be inserted into orbit at 32.5 degrees north latitude at 185 statute miles in altitude over Bermuda. People were already adding a new word to their vocabularies, EVA. It stood for extravehicular activity. Some were uncertain whether you said EVA or EVA, but regardless of the pronunciation, it would become an abbreviation of our time. The flight plan called for EVA to begin on the second orbit. Somewhere over Hawaii, the pilot was to open the hatch of a depressurized cabin and stand up. Over the west coast of the United States, he would leave the spacecraft and expose himself to space. For 12 minutes, he would perform maneuvers over the United States. He would return to Gemini 4 and continue the mission as the spacecraft neared the night side of the Earth over the Atlantic. This was the flight plan. A special EVA suit and life support pack had been designed and tested by NASA engineers in the Crew Systems Division. The EVA helmet has 3 visors. The inner visor is the normal suit visor which seals in suit pressure. Over it are 2 special visors. They are detachable and need not be worn throughout the entire mission. The outer or sun visor is easily recognized from its gold coating. It reflects both visible light and infrared rays. With it attached, only 10% of the sun's visible light is admitted. Beneath the sun visor, but not visible here, is an inner protective visor made of polycarbonate plastic. The Gemini suit has layers of aluminized mylar, nylon, and felt. In combination, they protect the astronaut against temperature and space particles. Special overgloves are worn to guard against extremes of space temperature if the astronaut should grasp the spacecraft during EVA. As the astronaut leaves Gemini, he is attached by a supporting umbilical line 25 feet long. The umbilical is actually one assembly consisting of 3 elements: a nylon tension line, electrical wiring, and an umbilical line. The nylon line or tether is shorter than the umbilical line. It takes all loads exerted during EVA and can withstand 1,000 pounds of pull. The electrical wiring enables the astronaut to maintain direct communication with his command pilot. It also records biomedical readings for ground surgeons. The umbilical line furnishes oxygen to the suit from the spacecraft's primary oxygen system. The life support pack mounted on the parachute harness contains an emergency oxygen bottle. If the umbilical line should fail, the astronaut would have enough oxygen to support him for at least 9 minutes, more than enough time for him to return to the spacecraft safely in an emergency. The pilot also carries a small maneuvering unit during EVA, the so-called space gun. Designed by NASA engineers of the Flight Crew Support Division, the gun provides a limited amount of thrust from compressed oxygen for basic maneuvering experiments. Gemini 4 is counting down on the launch pad. As the count goes into its final 2 hours, the crew arrives at pad 19. There have been no holds. The weather is good. The astronauts enter the elevator and ride it to the Erector White Room, which surrounds Gemini 4. The crew enters the spacecraft. The hatches are sealed. 7:32 Eastern Standard Time. The crew is now a part of the countdown. They begin checking out the spacecraft systems. It is T-minus 100 minutes. The launch vehicle and spacecraft continue the clean count, interrupted only by a balky erector which didn't want to lower properly. That cost us some time but presented no serious problem. At T-minus 30 minutes, the pad was cleared. Now there is just a spacecraft, launch vehicle, and 2 men on top of it.
All systems are good at this time. The launch control at the Cape. T-minus 10 minutes and counting.
6 minutes before launch, the spacecraft test conductor signed off to the spacecraft with these final words. Okay, Jim, have a good flight.
5, 4, 3, 2, 1, 0. Ignition. Start.
Liftoff.
At 10:16 Eastern Standard Time, Gemini 4 was on its way.
We have a roll program initiated.
Flight to clocks have started. And in sync. Roger.
Roll program completed. McDivitt reports. And the pitch program has been initiated.
Roger.
Mark 50 seconds and we're go. Guidance reports a go. The flight trajectory looks very, very close to right on the nominal value.
Looks good. Flight data pretty noisy, but we're okay. Flight Fido, good on Mod 3, little high.
And Jim McDivitt reports Gemini 4 is go for staging, which will occur in a very few seconds.
Just go.
We have staging, and it's been confirmed here on the ground.
Thrust looks good.
Gemini 4 entered orbit with an insertion velocity of 25,745 feet per second, within 11 feet per second of planned velocity. The apogee of the first orbit was 177.6 statute miles. The perigee, 100.8 statute miles. Command pilot McDivitt started to work at once, attempting to fly an airplane formation with the second stage of the launch vehicle. The full resources of NASA in Houston were on hand to support Gemini 4. From a new 3-storied building, flight controllers at the Manned Spacecraft Center assumed direct control of the mission for the first time in the space program. The mission director now checked the status of a possible rendezvous.
Ask him about his track with the launch vehicle.
Roger. I haven't decided this time. It's directly below me, about 400 or 500 feet up at our first downhill. Roger.
Everything seemed favorable at that time. But as the first orbit progressed, the second stage of the launch vehicle drew away.
Roger, Primus. We still have the booster. We're out quite a ways from it now. It's taken a little more fuel than we had anticipated.
To really make a major effort to close this last thing or to save the fuel?
The answer was almost immediate from the mission director.
You might tell him, as far as we're concerned, we want to save the fuel. We're concerned about the lifetime more than we are matching that booster.
Okay.
And that was it. Okay. The second stage of the launch vehicle went on to become simply Space Object 1391. It would burn up over the mid-Atlantic 2 days later.
Gemini 4.
Okay, we're giving you a go for your EVA at this time.
Okay.
The crew started their checklist for EVA, but Command Pilot McDivitt decided not to rush things. He elected to go for EVA on the third revolution.
Hawaii, Gemini 4.
Go ahead, Gemini 4.
Next pass around. I don't think we want to try it.
Very good. Tell him
Roger,
we're
I
happy
understand.
with that.
Next pass around.
Tell him we're happy with that.
Most of the world waited 100 miles below. The crew had completed final preparations. The cabin was depressurized and the hatch open. Coming up on Hawaii, McDivitt reported that he was satisfied and ready to begin EVA.
Surgeon, you ready to have him get out?
Roger, flight, we're go. He's got some nice elevated rates, which we expected, and he's really speeded it up, but he looks great. Let's go.
Okay. Hawaii, Houston flight.
Houston flight, Hawaii, Capcom, go.
Tell him we're ready to have him get out when he is.
Gemini 4, Hawaii, Capcom. We just had word from Houston. We're ready to have you get out whenever you're ready. Okay, we've got our go now, is that right?
Affirmative.
Okay, we're still doing a little work right here.
Roger, understand. Get his status, Hawaii.
Gemini 4, Hawaii, Cap. Durham.
Okay, I'm separating from the spacecraft.
Okay, separate from the spacecraft at this time, Hawaii.
Okay, my feet are out.
Okay, your feet are out.
I think I'm dragging a little bit, so I don't want to fire the gun yet.
Yeah,
Okay, I'm out.
okay, he's out. He's close to free.
Okay, I put a little roll in, took it right out. Am I in your view, Jimbo?
Well, you know, I can't see it on the screen.
Don't sweat it, I'll come over to you.
Yep, there goes your glove. Now we just let it go.
All right. Okay, I rolled off and I'm rolling to the right now. Under my own influence. There goes a... Looks like a thermal blast, Jim.
It is, yes.
All right. Now I've come above the spacecraft. I'm coming back down now. I'm under my own control. Okay, I'm coming over.
You look beautiful.
I feel like $1 million. I'm coming back to you. The gun works real good, Jim.
Let me get over here where I can see.
Yeah. Well, I got me upside down. Okay, don't fire the thrusters.
Make that flag look pretty.
Yep. Okay, I'm right by the stud antenna now.
Okay. Listen, let me get some notes for you. I ought to be getting some tremendous pictures of you. Let me try again with the archival.
Okay, I think I've exhausted my
Okay.
air now.
Stay right there.
I had very good control with it. I just needed more air.
Okay, stand by. Let me take a couple pictures of those.
All right.
Tell them what you think.
That's right. Capcom, it's very easy to maneuver with the gun. The only problem I have is I haven't got enough fuel. I've exhausted the fuel now, but I was able to maneuver myself out front of the spacecraft back. I maneuvered right up back on the back of the adapter. Just above Jim, came back into his view. This is the greatest experience. It's just tremendous. Right now, I'm standing on my head, and I'm looking right down. It looks like we're coming up on the coast of California. As I go in a slow rotation to the right. There's absolutely no disorientation associated with it.
One thing about it, when Ed gets out there and starts wiggling around, it sure makes the spacecraft tough to control.
Okay, I'm drifting down underneath the spacecraft. There's no difficulty with recontacting the spacecraft. It's all very soft. Particularly as long as you move nice and slow. I feel very thankful to have the experience to be doing this. I'll bring myself in and put myself out in your view, Jim.
Is he taking pictures?
Okay, do you want me to maneuver for you now, Ed?
No, I think you're doing fine. What I'd like to do is get all the way out, Jim, and get a picture of the whole spacecraft. I don't seem to be doing that.
Yeah, I noticed that. You can't seem to get far enough away.
No.
Texas, remote your air to ground. California, go local.
I'm coming back down on the spacecraft. Listen, it's all the difference in the world with this gun. When that gun was working, I was maneuvering all around.
Just for your information, Ed, we're only down to 48% on our O2.
Okay.
DCS O2 pressure is about 830, so stay right up there.
Let me get a picture of it.
Can you see the camera here?
Yeah. No, not now. I'm out of it.
You got about 5 minutes.
Okay, I will let myself go out now.
Gemini 4, Houston.
You know, Ed, the thing about the reference we were talking about looks like it's to your right.
Yeah, you don't even need one.
Gemini 4, Houston, Capcom.
Josh, this is Jim. Got any message for us?
The flight director says get back in.
Okay.
One. Where are we over now, Jim?
I don't know. We're coming over the west there, and they want you to come back in now.
Back in?
Back in.
Roger, we've been trying to talk to you for a while here.
Coming in.
You got about 4 minutes till Bermuda LOS.
History will record that Command Pilot McDivitt opened the hatch at 2:42 Eastern Standard Time. And a little after 3 o'clock along the eastern seaboard, Pilot White had opened up a new frontier for Americans to explore. In 21½ minutes, EVA was completed. Inside the spacecraft, the crew was faced with a problem. The hatch would not close. That day in St. Louis, when McDivitt took apart the locking mechanism, now paid off. The hatch finally closed. The cabin was repressurized and the mission settled back into its 4-day cycle. The crew was busy stowing the extra equipment.
What do you say, Gus?
He said he's busy and he'd rather not talk to us.
Roger.
America settled back into its daily routine. TV and radio returned to their regular programs. News reporters and editors concentrated on other stories. Like their earthbound counterparts, the crew settled down to working, eating, sleeping. But most of us have not flown in orbit. It might seem that 2 men in space for 4 days have considerable time hanging over them. What is it like? Your basic job is that of a space test pilot. And like all test pilots, you must follow a careful routine. Each spacecraft system must be checked out on a planned schedule. You verify your readings with ground control. It goes like this.
Roger, give me the status. Can you give me the battery readouts, please?
Roger, stand by, they're coming.
Gemini 4, you can turn your radiator, correction, your secondary pump A off. You've operated to normal. Your radiator looks good.
Roger, evaporator normal and secondary pump A off. Secondary looks good.
Okay.
In the past, an astronaut stuck very close to the basic job of flying a mission, performing as many simple experiments as his flight plan permitted. But the 4 days of Gemini 4 gave Command Pilot McDivitt an opportunity to live in space and plan work on a scale impossible before. His flight plan included 11 onboard experiments. For convenience, they may be roughly divided into medical, measurement, and photographic categories. There were 3 medical experiments: in-flight exercise, in-flight phonocardiogram, and bone demineralization. The 5 measurement experiments included measurement of radiation, spacecraft exterior, radiation, spacecraft interior, measurement of the electrostatic charge accumulated on the spacecraft exterior, measurement of the direction and amplitude of the Earth's magnetic field, sextant-type measurements for navigation study. And finally, there were 3 photographic experiments: synoptic weather photography, synoptic terrain photography, Earth limb photography. All 11 experiments are important in increasing our knowledge of how man will live and work in space, but the photographic experiments are visually more interesting to us. As Gemini 4 swept over Africa, it looked down on the ancient Nile Delta from approximately 120 miles in space. In a single photograph, it caught a view that includes portions of 7 countries in which some 25 million people live. Experts identify Alexandria dead center screen at the bottom of the frame. This is Port Said, entrance to the Suez. Tel Aviv and the Dead Sea, with their long historical associations, are left screen. And to the right, almost parallel, lie the Red Sea and the Gulf of Suez. The Earth's limb, or boundary layer of red and blue above the atmosphere, was the subject of another experiment. Reduced to a gray scale by filters, these photographs will be studied with a microdensitometer to determine the excess elevation of the blue limb above the red as an aid in space navigation. The experiments were conducted throughout the entire mission, and all were completed. On the second day, as Gemini 4 came within range of Hawaii, it set a new American space record. Everyone was pretty casual.
Also would like to congratulate the new American space flight record. Congratulations. Roger, we got quite a few more to go.
People went to work and returned home. In many parts of the country, it was already summer. With the weekend coming up, the cars were heading for the beach. The mission of Gemini, to live and work in space for 4 days, went on. Food has been planned as a working man's ration. 4 meals a day, 2,600 calories. Laid out on a table, it looks a little different from a regular meal. Plastic packages with bite-sized meals or freeze-dried food to be reconstituted with water. But it was good, solid, everyday fare. Meat, salmon, chocolate pudding, chicken, potato soup. After the first day, the astronauts ate the prescribed 4 meals a day. They would come down with only a portion of the last meal left. But sleep in space required an initial adjustment by the crew. It was somewhat like sleeping out under field conditions. Each astronaut showed individual patterns of response to the new environment, and White seemed to sleep more restfully than McDivitt. During the final 2 days of the mission, Command Pilot McDivitt took a series of formal and informal motion picture shots with a 16mm camera mounted at the pilot's window. The camera turns inward. For a brief moment, we are able to ride tourist class with Gemini 4, watching the crew at work. We catch a glimpse of a space sunrise, flaring in brilliant color over the Earth's horizon. Using the same camera, McDivitt photographed ground objects, including this small island in the Gulf of Mexico off the Texas coast. On another occasion, he photographed approaches to Yuma, Arizona. The detail seen here shows great promise for scientific exploration of the Earth, heretofore impossible. Using this technique, we could chart the major currents of the ocean, study weather patterns, and map the geology of the Earth. Shortly after the new shift came into mission control on the 4th day, the first spacecraft problem arose. The computer did not function.
Be advised, even when I turn off the computer battery switch, I still have the malfunction light on.
We'll work on it. We'll give you an answer when we get one.
The malfunction was pinpointed in the 49th revolution. When it did not clear up, Mission Director Christopher Kraft made a decision. Gemini 4 would go to a rolling re-entry. He immediately queried the command pilot.
Hey, Gemini 4, what is your feelings on a rolling re-entry versus a 90-degree bank angle? We're recommending rolling here.
Yeah, get the job done, so why don't we go ahead with it?
The 60th revolution, the 4th day, and the computer out, but no problem. The flight surgeons made their final checks. Both men were busy stowing equipment. Now it was the 62nd revolution, coming up on Hawaii. The orbital attitude and maneuver thrusters were fired to assure orbital decay and re-entry if the retrograde rockets did not fire. Now television and radio were back again. A nation paused on a Monday morning, waiting to fly in with the crew of Gemini 4.
Give him an 8-minute mark to retrofire.
Gemini 4, Hawaii, stand by for an 8-minute mark to retro 5. 2, 1, mark. Mark.
Gemini 4 would fly the same type of re-entry as Gemini 2, an earlier unmanned flight. We will illustrate the re-entry of McDivitt with film from that flight. This is an onboard camera, Gemini 2, looking through the spacecraft window. The film is reproduced at 4 times normal speed.
Feeling great. How about you?
Gemini 4, Houston, Capcom.
Well, Houston, Gemini 4.
Roger, you started your rolling re-entry? Roger. Your weather is still very good, Jim.
Okay.
Communications with the ground break off, but the onboard tape recorder is running. We listen to 2 men returning to Earth after 4 days in space.
Look at us. We're making some fire, too. Yeah, we're putting our ionization layer out. They're not reading us anymore now, probably. There goes Florida. Is that Florida? Ugly fish. See it on your side? Yeah. They're red hot, you know. Sit back and relax. We ain't gonna do much about it from here out. No. Get ready for the cheek, Ryan. I think we got now about 5 feet. What would you say, Bill? It's only going up and yeah. You know, it's kind of nice to have some cheeks back again. Yeah, it is. It's making me dizzy going around in circles. Look at the paint coming out my window. Roger, Kickapoo. We're just about ready to put the parachute out. Stand by. Okay, parachute's coming. There's the read. There's the T-read. And it's a good one, isn't it? There's the read. Nobody can read me now, but does that parachute look great? You're not kidding.
During re-entry, the USS Wasp launched 13 search and recovery aircraft. Gemini 4 splashed down at 12:13 Eastern Standard Time, June 7, 1965. It was sighted by a search aircraft 7 minutes later. Navy frogmen swiftly attached the flotation collar, and at 12:39, Command Pilot McDivitt opened the hatch. Both men took a deep gulp of fresh air. 4 days in space had ended. The command pilot requested a pickup by helicopter, and in a matter of minutes, the prime recovery helicopter had the crew safely on board. They were flown to the deck of the Wasp. Admiral William McCormick, commander of the Western Atlantic Recovery Forces, and his staff offered the first formal congratulations on the flight. The crew then walked to the carrier elevator, bound for their physical examination. A long series of physical examinations would follow in the days ahead. The condition of both astronauts was excellent. While the doctors were examining the crew, another group of men were scrutinizing other data just as closely. The engineers who designed the spacecraft and solved the problems took a hard look at what happened. They analyzed miles of coded tape which spell out each detail of the mission. The results were more than a demonstration of man's ability to go into space and return. Gemini 4 was a major advance in manned spaceflight operations, the first time 2 men had spent 4 days in space. The crew, eating, working, sleeping in space, demonstrated that man can perform a number of functions in the exploration of space in a properly controlled environment and suffer no significant ill effect from extended spaceflight. Colonel White demonstrated that an extravehicular astronaut could travel in a precise manner from point to point. For the first time during an extravehicular activity, the spacecraft was flown with steady control by its command pilot. Colonel McDivitt also performed re-entry under manual control, further evidence that man can circumvent problems which arise by carrying out a primary operation in a straightforward manner. Gemini 4 was an encouraging landmark in relation to the future objectives of both the Gemini and Apollo programs.
From the earliest history of mankind, there's been a bright red speck of light in the night sky called Mars. For the last few hundred years, we've known that it's a planet, a place more or less like our own, a world in its own right. But a detailed knowledge of what Mars is like had to await the mission of Mariner 9, an unmanned spacecraft which went into orbit around the planet Mars in late 1971 and worked for almost a year.
A geologist looks at a planet to first understand the processes that are going on there, the things that are affecting the development of its surface at the present time. But even more important, we try to look back in the past to place the events that have taken place over a long period of time, to understand what happened early in its development, in the middle part of its development, the things that are happening now, and to predict what might happen in the future.
For a biologist, one of the great scientific opportunities of our time is the search for life on Mars. That question is so important, it will change our whole concept of life. It will change our whole concept of how life originated. The question is not only whether there is life on Mars, but whether that life has a separate origin from our own life, life as we know it.
When Mariner 9 was placed into an orbit around Mars, it saw a planet 1/2 the size of Earth, blanketed by a gigantic dust storm. For almost 2 months, scientists could see only blurred pictures of the top of the storm, or the ice and snow of the South Pole shining dimly through the dust, and several dark spots, apparently mountain peaks protruding up through the storm. And then the great clouds of dust receded, and the long weeks of frustration ended with one magnificent and exciting word: volcanoes. The photographs bear little witness to the violence in which these volcanic mountains were born. On Earth, the eruption of volcanoes created the atmosphere and produced the water that fills our oceans and rivers. On Mars, the same magic of physics and chemistry created a thin alien atmosphere and provided a source of water on a planet known to be drier than the Sahara. The exploration of Mars by early mariners photographed about 10% of the surface in brief encounters as they flew past the planet. But it is Mariner 9 that explores all of Mars and reveals a planet beyond speculation. The intricate spacecraft, operating at a distance of over 100 million miles, is commanded by a complex system of men and machines on Earth. 6 mission experiments yield results that can be woven into a total picture of a planet. As the spacecraft orbits Mars, the density of the atmosphere is measured by radio waves as they pass through the atmosphere on their way to Earth. The thin Martian clouds are scanned in the infrared to determine if they are carbon dioxide or water. An infrared instrument continually measures the changes in surface temperatures, ranging from minus 150 degrees Fahrenheit on the night side to as high as 70 degrees at noon on the equator. The height of mountains, the depth of canyons, and the gases in the Martian atmosphere are measured by invisible radiation in the ultraviolet and infrared wavelengths. Analysis of subtle changes in the orbit of Mariner reveals that Mars has an odd bulging shape, and this shape is a new clue to its internal structure. 2 television cameras photograph and map the surface of Mars. In nearly a year of operation, they transmit more than 7,000 photographs. Of these, over 1,500 are specifically taken to ensure that the entire Martian surface will be mapped. The photographs are carefully matched, precisely positioned on a globe, and skillfully fitted together. This shadow on the surface of Mars is cast by one of its 2 moons, Phobos, only about 13 miles long. The second moon, Deimos, is even smaller. They are the darkest objects ever photographed in space. Primitive chunks of rock battered by meteoroids, their origin is unknown. This is the face of Mars, photographed by earlier mariners. Here, a visitor might think he was on our moon, that this planet too was unchanging and dead. But transported to the other face of Mars revealed by Mariner 9, he would see fresh evidence of a living, changing planet. The old craters here have been long since covered by immense flows of lava. Thin white clouds form and drift across the dark blue sky. In the distance, he would see the long, gentle slope of a great volcano. Intense small dust storms scour canyon walls into sharp ribs of ancient rock. Near the poles, he would see a great series of ancient terraces, each layer composed of a mixture of dust and snow deposited by the wind. Each took thousands of years to form. Each is an episode in the history of the planet.
The exciting thing that we discovered, there were many of them, but one very exciting thing that we observed in the middle of the mission was that things were changing before our very eyes on the Martian surface. For example, in 13 days, an area about 7 miles across discontinuously appeared, just hadn't been there before, suddenly it was there. Now that kind of change had been observed, but from the Earth and on a larger scale, for 100 years. It was called seasonal changes, and the early observers imagined that there was plant life on Mars, and that in local spring and summer the plants grew. They darkened the landscape and heightened the coloration of the landscape. Well, we proposed before Mariner 9, my colleagues and I, that instead what was happening was that there were high winds that were uncovering the dark material, dark rocky stuff, by blowing off bright, fine particles. And the changes that we've seen on Mars happen during the course of the mission are consistent with this kind of idea. So it looks as if the seasonal changes of Mars are not due to biology, but due to weather. We calculate that the winds are maybe as much as 200 miles an hour in such a storm. And you see, you have to have very high winds to make that thin Martian atmosphere pick up fine particles from the surface. So while most of the time it may be nice and calm, there are storms which are much more violent than any we see on the Earth. Now, if you have very fast winds picking up all this fine-grained sand, that's a source of erosion and abrasion much more serious than any wind-blown erosion we know about on the Earth. It breaks things up, makes things collapse. It also picks up things and denudes landscape of overlying sand and dust. It's an exceptionally dynamic environment. In some respects like the Earth, in some respects quite different. It's its own planet. There are old parts of Mars which are cratered by hunks of rock falling down into Mars and making holes. In some of those craters, there are these strange black splotches. At least some of those splotches, on closer inspection by Mariner 9 cameras, turn out to be vast sand dune fields, another indication of wind-blown sand and dust on Mars.
There is a similar dune field in the Mojave Desert in Southern California. That is, the overall form of the two fields and the height and spacing of the larger dunes are alike. However, the complex pattern that we see here shows that the wind directions change frequently. On Mars, the wave pattern indicates a consistent wind direction.
Here is an astounding feature which no one expected on Mars. An enormous rift valley, almost 3,000 miles long, comparable to the largest such feature on the Earth, a sign of great geological activity.
In this model, the flat surface of a large Martian plateau is cut by the Great Rift. A smooth sloping ravine drops abruptly to the bottom of the canyon 4 miles below. The small peaks on the canyon floor were once part of the plateau surface. Today, this great fracture in the crust of Mars is 75 miles across. The original fault has been widened and shaped by various forms of erosion. Great landslides are triggered by quakes that shake the crustal rocks. Wind-blown dust strips the receding canyon walls. Some side canyons may have been deepened by running water. Melting of underground ice, followed by slumping of walls, further erodes the great fault. This Rift Valley, of which we have seen only a small part, is so huge that it would span the United States. And the Grand Canyon of Arizona would fit inside one of the smaller tributaries.
And as another and even more spectacular sign of geological activity on Mars is this enormous volcano, hundreds of miles across It's the largest volcano in the solar system so far as we know. It's a young object because it doesn't have very many impact craters in it, meaning that geological activity on Mars has been occurring in very recent times.
This is a model of the volcano. Its base measures 370 miles across, and the peak stands 15 miles above the plain. The flanks of the crater bear the familiar tortured patterns left by violent eruptions of molten rock. The walls drop steeply to a scarred, blackened floor. Frozen lava lakes mark with rough circles where the interior fires of the planet forced their way to the surface and built a mountain. This is where the atmosphere of a planet is born, in searing heat that transforms solid primitive rock into thin vapors. Today, the crater looks dead, frozen into a rigid page in a textbook on the evolution of a planet. This is not an old volcano. To a geologist, it is young, and no one can say if it is alive or dead. In this volcanic field near Flagstaff, Arizona, there are hundreds of volcanic vents, some as old as 2 million years. The youngest of these, Sunset Crater, is similar to the small volcanoes we see on Mars. And the lava flows are the same as those we see on the flanks of the larger volcanoes.
I'm standing beside the basaltic lava flow that comes out of Sunset Crater, and the great jumble of blocks that you see here are caused by the fact that the lava comes out as a liquid, but it chills on the outside, and the interior of the flow keeps moving, and it breaks up the outer edge into this great mass of jumbled blocks. It's very similar in size and form to the lava flows that we see on Nix Olympica on Mars. In many Mars photographs, we see long, sinuous ridges that go across the great lava plains. We're sitting on a feature that's very much like those. We think the way this feature formed is that the still liquid lava down in the center of the flow keeps exerting pressure. It lifts the top up, finally breaks it, and then squeezes out through the frozen crust.
And here is something which no one guessed would exist on Mars at all. This is one of hundreds of little channels. This is actually not so little. This is a few hundred miles long. Channels which look for all the world as if they've been cut by running water. Here's a close-up of the inside of one of those channels, and it has the characteristic patterns of terrestrial stream beds. But the trouble is there isn't any liquid water on Mars. The pressure on Mars is so small that it can't keep a lid on liquid water. If this is due to running water on Mars, it must have been made at a time when the Martian climate was very different from what it is today, at a time when Mars had much more Earth-like conditions.
This is a model of a section of a 3-mile-wide channel north of the Martian equator that seems to be formed by a broad flow of liquid water. It is similar to drainage channels on Earth that are fed by rainfall. Parts of this channel also show evidence of wind erosion and softening of contours. The islands appear to be similar to sandbars formed by rivers on Earth. They might be heavy gravel or perhaps solid rock.
I personally don't see any escape from the idea that running water is what carved out those channels. But if that is the case, then we must imagine that Mars was one time, not so long ago, very different from Mars today. Right now, we have a Martian atmosphere which is thin, a surface which is cold. But when those channels were cut, if they were cut by water, and I think they are, then you must have had a much thicker atmosphere, much warmer conditions, and a lot more water around than you have today.
Volcanic eruptions are the source of water on Mars. With each eruption of lava, water vapor is spilled out in the atmosphere. It is stored in two different ways.
The first way is in the residual polar caps. This is the North Pole of Mars, and the cap shrinks down to about 5 degrees. It starts at the end of winter almost 50 degrees across, and we think that polar cap is very thin carbon dioxide ice, and it shrinks very quickly to this little residual cap, and we're still debating as to whether that's water ice, carbon dioxide, or dry ice, or a mixture of the two. The second way that it's stored is in these regions where the frost has disappeared from the surface, but we think is still stored underground as permafrost, that is, water frozen into the pores of the rock. We were able to photograph several different kinds of clouds with Mariner 9. This photograph is of one of these clouds. It's the edge of the North Polar Hood. It covers the whole northern region of the planet, and this is the southern edge of the hood. Here you see an ice-rimmed crater and the clouds that form downwind. By measuring the temperatures and the elevations, we're able to understand the composition of these clouds. This particular cloud, the temperature was critical, and we know that it was made of dry ice or carbon dioxide ice crystals. Near the great volcanoes, we saw clouds that were much lower and much warmer. We also got spectral lines that proved that these clouds were composed of water ice crystals.
Just as the study of the climate of Mars should, I think, help us understand the climate of the Earth, I think the study of the biology of Mars will help us understand the biology of the Earth.
The big question for the biologist is, what is life? What do we mean when we say life? We're really only familiar with one form of life, terrestrial life.
Terrestrial life, life on Earth, carries a trademark revealed by biochemical analysis. All living things on Earth are composed of combinations of molecules, some as simple as water, which is fundamental to life as we know it, others of great complexity. One of these combinations, proteins, forms the enzymes that direct the complex chemistry of life. Another, nucleic acids, are genes contained in chromosomes, the basic unit of life. These combinations of molecules distinguish living things from non-living systems. One other element needed to make a living system work is a method of reproduction. DNA is a molecule containing the genetic message, the blueprint for future generations. This genetic code is the same for all living creatures, for all life, which means that there is really only one form of life on Earth.
If there is life on Mars, then there will be a simply fabulous expansion of the perspective of the biologist. Because all the organisms on the Earth, even though they seem to be different, are fundamentally the same. Their chemistry is all identical. And they're just wrapped in different kinds of wrappings. Us bacteria and us people and us plants and us protozoa, we're all the same on the inside. Now the question is, are Martian organisms the same on the inside as us? Is life everywhere, does it have to be the same as us? Or are we just one example of a vast array of possible kinds of biochemistries? Well, there's no way for us ever to answer that question, no way for us to determine the generality of life on Earth, except by looking for life elsewhere. And the nearest candidate planet is surely Mars.
In 1976, 2 Viking spacecraft will place landers on the surface of Mars. One major objective is to search for life in the Martian soil.
But what kinds of life forms might cope with the special problems of Mars? The Mars atmosphere allows deadly ultraviolet radiation from the sun to penetrate to the surface. Life forms on Mars may have silica shells to protect them against the radiation. We know that Mars is very dry. Life forms on Mars may have developed special ways of preserving their water content, And those forms may not look familiar to us. I can even imagine forms of life having leaf-like structures, oriented by the sunlight, possibly of unusual colors. This is one of the reasons that we want to have color in our cameras. I could imagine a kind of plant. A plant is perhaps how one would identify it, that is indeed an ice eater, with fine root-like structures, searching not for liquid water, but searching the permafrost, reaching down to get at that ice. Another solution to the problem of water might be an organism that eats rock, one that literally picks up the rock, eats the water, and spits out the rock. An imaginative idea, but not wholly ridiculous. We don't know of such creatures on Earth, but it is possible, and people have speculated along those lines. We're not quite sure how to search for life on Mars. We do the obvious. Microorganisms, the small creatures, are always associated with higher forms of life, so it's microorganisms we're searching for. A small microbe could adapt itself possibly to the cold Martian winter, to the dry Martian summer, to hostile Martian atmosphere, or even to the sub-zero temperatures of the Martian night.
This is a full-scale model of the lander spacecraft. This device contains a 10-foot extendable boom. It reaches out, picks up a soil sample, and returns it to an instrument inside the spacecraft, which will then perform 3 life search experiments. The first experiment will assume that Martian life is similar to Earth life. It uses Martian soil and Martian atmosphere. The soil is soaked in a liquid containing a large quantity of water with a mixture of foodstuffs used by microscopic life on Earth. If Martian life forms eat the nutrients, they should excrete gases in the process, as do microorganisms on Earth. This will change the gases in the test cell. Any changes will be detected and will be evidence of life processes. The second experiment is half Martian and half Earth. The soil sample is moistened with only a little water containing foodstuffs that scientists think exist on Mars. The foodstuffs are tagged with radioactive carbon-14. If life processes take place, then carbon gases released in the process will contain the radioactive tracer and can be detected. The third experiment is based on Martian conditions. It uses Martian soil, Martian atmosphere with scarcely any moisture, to which is added radioactive carbon gases, and simulated Martian sunlight, minus the ultraviolet radiation. If Martian life forms are growing and multiplying in the Martian soil, it is assumed they would use some of the Martian atmosphere in the process. The atmosphere, tagged with carbon-14, should be metabolized into the bodies of the life forms. After allowing time for life processes to take place, heat will be used to break down solids into gases. Detection of carbon-14 in those gases will be evidence of a life process.
It always happens in the history of science that as your perspective broadens, you learn more about what you left at home as well as what you went out to seek. And so it may be that in the long term, the greatest boon to science and to mankind from the exploration of Mars will come in terrestrial biology. It's just a speculation on my part, but I think there's a good chance that that will be the case.
We have seen the planet Mars, in one sense, for the first time through the eyes of Mariner 9. And it was not quite what we had expected. How can a planet bear the scars of great raging floods and the gentle tracing of rain when liquid water on its surface vanishes into thin vapor or congeals into solid ice? The possibility now of large amounts of frozen water on Mars may hold the answer to one of man's basic questions. Has life developed only on Earth? Or is there life elsewhere? Mariner 9 has given us fresh confidence that the answer might be yes, and has told us where to look. The landing sites for Viking are now neatly inscribed on our new maps of Mars. And in 1976, the search begins.